And I just wanted to go over it in case there was any confusion about it. So the first question is, what does the slope on a distance time graph indicate about the object's motion? Well, the slope represents the speed of the object, and if we had a direction, then this distance would then be referred to as displacement, and if that had been the case, not speed but velocity would have been what it represented. Okay, so next is what does the slope versus time slope? Sorry, what does the slope of a speed versus time graph indicate? That is simply the acceleration. So this one here, really the speed should be velocity because acceleration is a vector quantity and it has to have direction. So acceleration indicates the slope, and this would be really for a velocity time. So you'll see that every now and again on worksheets and where the speed is just interchanged with the velocity, but it really shouldn't be. Okay, questions 3 through 8 refer to the following generic graphs, and you have to choose which go with which. So which shape fits a distance time graph of an object moving at constant non-zero speed? So non-zero, well, this one would be a zero speed. This one would be a zero speed because there's zero slope. So this is a constant velocity. The slope is constant. The line is linear. It's not curved. So here we'd have C. Now next, which shape fits a speed versus time graph of an object moving at constant non-zero speed? So if this were a speed or velocity time graph, then this is some non-zero staying the same amount of velocity type of graph. So this one should be B. Which two shapes fit a distance time graph of motionless object? Okay, so just looking back, if these were distance time graphs, then this one would be motionless. It's not moving. It's got a zero slope. And this one would be motionless. It's got a zero slope. So A and B would be the answers for that. Which shape fits a speed versus time graph of a motionless object? That one would be A, where the graph looks like this, and the arrow goes right along the x-axis. So motionless would have zero velocity, and that's what that one would have, zero amount of velocity. Okay, which shape fits a distance time graph of an object that is speeding up at a steady rate? Well, that would be D, speeding up at a steady rate. Okay, now it's difficult to know if it's speeding up at a steady rate, but let's assume that curve is of a linear acceleration. Which shape fits a speed versus time graph of an object that is speeding up at a steady rate? So if it were now a speed versus time graph, we'd be looking at option C. Option C is velocity time, and this is showing that with time the amount of velocity is increasing at a steady rate. Okay, moving on to the next. Which of the following units is equivalent to meters per second per second? That would be the same as this, and that represents an acceleration. Which of the following units corresponds to the slope of a distance time graph? So the slope on a distance time graph is velocity or speed, and then we've got this as our units, meters per second. Which of the following corresponds to the slope of a speed versus time graph? That would be the acceleration, and the units for acceleration in meters per second are right there. Okay, turning the page over, you've got this set of data. You can see right away we've got distance and time, and oddly enough, the amount of distance for each interval is staying the same at 20. So 20 meters per interval of time. Now look at the time. 0 to 4.5, 4.5 to 6.3 to 7.7, 8, 9 to 10. Well, this is getting shorter and shorter. So you've gone the same amount of distance in less and less time. That should mean to you that you're accelerating. Okay, so keep that in mind. So which of the following distance time graph corresponds to the data? So if it's a distance time graph and it's accelerating, it has to be this curved one right here. So this should be C. Okay, now here is the data just copy and pasted into an Excel spreadsheet. And what I've done here is I've plotted the data, and then I have asked the program to assume that that data would best fit on a quadratic formula, and give me an r² value too. So when r² is equal to 1, and this might as well be 1, then the data points are perfect. Okay, so here we've got a y for the equation. Y equals 0.9982. We might as well say 1. So that would be 1x squared, or just x squared, plus 0.073. So let's leave that 0.073x minus 0.1047. Now the reason that I'm copying this down is that when you get a little further on in your math, you're going to learn how to take derivatives. Now what I'm going to do here, I'm not going to explain exactly all about it, but this will be taking the first derivative, and this is our distance time graph, and it fits nicely on a quadratic. It fits nicely because this r² value is close to 1. Okay, the derivative would be y prime is equal to 2x plus 0.073. Now what is this? This is the equation of the same data if it were on a VT graph. Okay, so that may not mean too much to you until you realize that we've got a linear graph, and the slope of that is 2. So the slope on a VT graph is acceleration. So the acceleration of this data is equal to 2 meters per second squared. Okay, because that would be the slope of the VT graph. Okay. Anyway, this is just not necessarily for Science 10, but for those of you who are really getting into math, and you see your future in math and science and engineering and whatnot, then you will definitely be seeing a lot more of this sort of thing. So I just thought I'd throw that in there for you guys. Okay, moving on. Which of the following descriptions matches the graph selected in 12? Well, that would be C, an object undergoing constant positive acceleration. Good. Which of the following speed versus time graphs corresponds to the table? So if it was the speed versus time, we would have a constant acceleration, and this one actually, the slope would be 2 meters per second squared. So we'd even know that if we did what's called a linear regression, and then take the first derivative. But anyways, the option is A. Which of the following description matches the graph you selected in question 14? That one would be an object undergoing constant positive acceleration, so that should be C. Okay, moving right along, a woman walks away from a starting point in a straight line. A distance versus time graph for her motion is shown to the right. Okay, describe the motion between 0 and 2 seconds. So 0 and 2 seconds is this part right here. You can see it's curved on a DT graph. You'd have to say something like she is accelerating. Okay. Next, fill out the table below. You do not have to show your work. What is the woman's speed from 2 to 4 seconds? Okay, so the speed here, we're looking at the slope of this section. So always be careful here and check to see what we're going up by. There's always a temptation to go up by 1, 2, 3 and think it's 3. But it's actually here, it's 2, 4, 6. And then on the x-axis, it's single digits. So we've got 6 up, so rise is 6 meters in 2 seconds. So we end up with 3 meters per second. So 3 meters per second. From 4 to 6 seconds will be from here to here. That's 0 slopes. That's 0 meters per second. And then we've got 6 to 8. We've gone up to in 2 seconds. So that will be 1 meters per second. Okay, I hope that helps.